So the schedule in terms of the structure, we've got 2 years, which are, both of those years have a similar structure here. The robot's actually going to be in 2 locations, in my lab, and it's also going to spend time in the Aware home. My lab, you can see here, it's pretty conventional. We do have a simulated living room and a hospital room. But the Aware home is not conventional, and what's nice is it's a real house. It's a freestanding structure on the Georgia Tech campus, and that's going to give us some advantages in terms of what we want to do. So for the first year, our goal, first of all, is to identify tasks that would be of value. We're going to be focused on porting software that we've already developed. And then we're also going to be developing some new software that really takes advantage of what we see as some of the great things about the PR2. In terms of the Aware home, we're going to really use that in 2 main ways. One is to be able to work with older adults in a realistic setting so that we can get better user studies and get more representative responses from them. And then also to evaluate our software in a realistic setting. Second year is quite similar, although from the software development side, we're really going to be focusing at that point, now that we have some information, on new capabilities for the PR2 that deliver on sort of what we hope are high-impact tasks for older adults. And the Aware home used in a similar way. Okay, so that gives you a sense of our plan. I want to talk a little bit about examples of some of the work we've done in the healthcare robotics lab that is going to influence our work on the PR2 and hopefully be ported over to the PR2. We have 3 mobile manipulators that we've built and developed software for in my lab. And one example of work is the point-and-click interface. The notion here is a person uses a laser pointer to provide a 3D location of the robot, and then the robot uses that, what ends up being a small volume in the world, to infer, given that application, what the user wants. In this case, it's an object fetching application, and the individual commands the robot to pick up objects, or actually to go, if you point to a wall, to go and reach out to the wall, notion being a precursor to operating lights and such. Likewise, if the robot's holding an object, you can point to a person, it'll deliver the object, point to a table, it'll place the object on the table. And we've evaluated this with users, both in terms of designating objects with various interfaces and delivering objects. And the thing I want to point out is that when we did these studies, one thing we definitely found was that preferences were really across the board in terms of what people actually wanted as the interface they were using. And so I think what would be great as a community, and hopefully we can make progress on that here, is to be able to define some sort of abstraction barriers in terms of what the interfaces should be. In our work, the robot didn't care which specific user interface the person used, as long as that user interface could provide a 3D location to the robot in its coordinate frame. And this really is closely related to what you find in a personal computer, where you provide a 2D location with a click and have that as an interface for a wide set of applications. But you could be using a trackball or you could be using a mouse. We have also done work on object fetching, and I won't spend really time here because Willow Garage has been doing a very nice job in this area, and we're excited to collaborate with them on that. But we have done a lot in terms of trying to evaluate it with respect to the objects that are important to these users, and in terms of lots of real-world variation, like lots of different tables and such. Also, we're going to be attempting to port our work in opening doors and drawers. I'm going to show you some of the most recent work on this in my lab, because this is collaborative work with Freiburg, specifically Jürgen Sturm and Wolfram Burgard. And what's happening here is the robot's able to open something. All it's given is a point-and-click interface. All it knows is the handle is approximately in this location, and I should hook onto it this way. After that, it uses this haptic interaction to infer the kinematics of the object. And so it didn't know that it was going to have, it has no model of the object, it doesn't know what the kinematics are, it didn't know that it was going to open downward, and yet it's able to do these things quite robustly. One of the things I'm curious about there, we're going to have to really find out how well we can port that to the PR2. So for example, we do use a force torque sensor in that work, and we do in a lot of our work we have things where you move out and you make contact with something. So we're interested to see how well we can port that sort of approach. I'll just briefly mention sort of the approach in my lab. We have this working hypothesis that we can do a lot of these fairly general tasks by composing fairly simple behaviors. And we think that has a lot of advantages, not the least of which is that if you have something that's simple, it's predictable. And because it's predictable, I think that has advantages for human-robot interaction, because a person's going to be able to know what to expect of the robot, and also for data-driven methods, because by having these low-dimensional behaviors, you have to collect a lot less data in order to build something on top of it. Also, in terms of our approach, it's definitely the case that we feel like performance is really an empirical question. You might have something that seems really simple in terms of behavior, and yet with respect to the statistics of real-world variation for the task, it's actually quite general. And so for us, we think empirical evaluation is especially important. So that's kind of some of the stuff that we'd like to port to the PR2. And now I want to talk a little bit about some of the new capabilities that we want to develop that have been inspired by the PR2. The first is just the PR2 is I don't know of a more robust, certainly my lab has not encountered a more robust and well-tested mobile manipulator. And so that gives us a chance to really do some exciting work, I think, in terms of data-driven methods. So specifically, we're going to be building a playpen for the robot. That means that whenever the robot manipulates objects in that playpen, the object always stays in the robot's workspace, so we can just let it throw in an object, or actually we're planning to make an automated object deliverer, or dropper, so that we can just let the robot run overnight and collect trials. And we expect that probably we can get about 100,000 trials of real-world grasping. If all 10 robots were to do this, that would be 1 million trials. So I think there are real opportunities for this sort of data-driven approach now that we have actually a robust robot. And with respect to that, we have this prioritized list of objects, so our plan is to really focus on the top objects in this prioritized list. We're also interested in manipulation and clutter. We've had a lot of success in laboratory testing, but in terms of moving things like object fetching out into the real world, we're going to have to deal with real-world clutter. And we've done some work now to be able to sort of characterize the real-world clutter by seeing what's actually out there, trying to find out what the statistics of real-world clutter looks like, and also to develop some methods that can do things such as find the surface when very little of the surface is visible. In terms of recent stuff, and this is where I think the PR2 comes in, this is an example of placing an object in clutter. And the key thing I want you to notice here is that we're simulating having nice, efficient, real-time 3D sensing. That laser rangefinder is tilting. There's a camera that's registered with it. Then it figures out where the surface is and where a spot is that it can place the object. And the problem is with that kind of sensing, where we're doing every 10 seconds or something, we're able to sense the world. It really limits what we can do, especially with respect to feedback-based approaches. So we're excited to really look at manipulation and clutter with the PR2, where we have the opportunity for real-time 3D sensing with point clouds. And then finally, of course, probably the most exciting part about this is really developing new capabilities for the PR2 that are really matched to older adults and what their needs are. And of course, that's something we're going to have to find out. That really is going to come from these user studies, and we'll find out. It's an exciting, open-ended part of the project. So that's all I have to say. I just want to re-emphasize the team that we have. A lot of people are going to be contributing to this, and we're very excited about it. So thank you very much.